Thank you, Dana. Thank you, Greg. And hello and welcome everyone to Introduction to Azure IoT Central. If you're joining us live, please feel free to use the chat to ask any questions you may have. Alternatively, you can contact me via email, social media, or you can also find me on the Microsoft Power Automate community forums, where I enjoy helping everyone learn more about Power Platform. My name is Cheng, and I'm a digital solutions architect at Komatsu Australia. I've been working with Microsoft low-code and pro-code technologies for over 15 years across Office 365, business applications, and Azure. I'm a Microsoft certified architect, DevOps engineer, Power Platform maker, and trainer. So the goal for today is to really provide you with an introduction to Azure IoT Central. We'll talk a little bit about IoT and what are the challenges around designing and building an enterprise-grade IoT solution. We'll then discuss how Azure IoT Central can simplify that entire process and really is democratizing IoT for everyone. We'll then go into IoT Central and demonstrate the type of solutions that you can build using IoT Central, Dynamics 365, and the Power Platform. So firstly, what is IoT? IoT, or the Internet of Things, refers to a network of connected devices that can send and receive data over the internet. So imagine being able to connect and interface with everyday physical devices and take data from these devices into the digital space, where you can then store, analyze, and transform them into actionable insights. IoT is already leading transformation across a number of industry verticals, from healthcare, agriculture, energy, oil and gas, and manufacturing, as an example. There's so many possibilities when it comes to IoT, with use cases around smart buildings and cities, autonomous vehicles, remote monitoring, and predictive maintenance. And no wonder it's predicted that by 2025, there'll be over 41 billion connected devices worldwide. However, despite this number, 70% of IoT initiatives fail. So why do you think that is? Well, when we talk about designing and building an enterprise-grade IoT solution, it starts with data on a device. But there's much more than that. We have to think about how we're going to connect to our application from our devices. We also need to think about how we're going to manage our devices across the life cycle. Once you've connected to the device, how are you going to store, process, and analyze this data? What's your presentation layer to visualize this data? And more importantly, how are you going to deliver actionable insights to your end users on the systems and applications that they use most? There's also important things like security, and also, as your solution and number of devices grow, scalability and disaster recovery. So there's a lot to think about. And fortunately, Azure provides many options and services that enables IoT solution builders to build their applications. And that really leads us to Azure IoT Central, which simplifies the whole process of selecting a device, connecting to your device, and extracting value from the data of your device. IoT Central is offered as a SaaS solution. It's built on top of Azure IoT Hub, as well as an ecosystem of other various Azure services. The great thing about IoT Central is that it abstracts away all that complexity I mentioned earlier of designing, building, and maintaining secure enterprise-grade IoT infrastructure, and really just lets organizations focus on transforming the business with IoT rather than be burdened by it. Another great thing about IoT Central is that it allows solution builders to extend and customize the standard functionality with little or no code. And we'll see how we can do this very shortly. So from here, there are two scenarios which I would like to go through. First, I'll introduce you to the IoT device that I'll be using, and then we'll move on to rules and actions. We'll look at how we can use rules to monitor the events coming in from our device and trigger actions such as creating an IoT alert into connected field service. In a second scenario, we'll take that further and look at extending IoT Central to stream data out to other Azure services and perform real-time anomaly detection using machine learning. Again, We'll integrate that with Dynamics 365 and close off the loop and send work order updates back into our IoT Central application. So with this, let's flick over to our IoT Central application where I can show you my device and talk about device templates. Device templates are one of the key concepts of IoT Central. They let your application know about what type of device you're connecting with, and also what your device is capable of. Microsoft provides a diverse library of Microsoft plug-and-play certified devices, as you can see. And the idea here is that you can purchase one of these devices off the shelf, connect it to the internet, and really start sending data to your application straight away without manual configuration, without worrying about device compatibility and developing firmware. At the heart of each device template is the device model, which is a JSON representation of your device using the digital twin definition language. The device model describes the capabilities of your device, the telemetry that your device can send, the properties that your device can store, and also any commands that your device can receive and execute. So the benefit of using an IoT plug-and-play certified device is that when you select a template, your IoT application already knows about your device and what it's capable of. This device template is also customizable. You can add additional capabilities, and you can also add additional cloud properties like I've done here. I've created a number of additional properties such as work order number, status, scheduled date, and technician name, and I'll be using these to store information from Dynamics in one of my later examples. So, Lamont, let's bring up our IoT device and show everyone what we're going to be using for our demos. So the device I'm going to be using is the MX chip. It's a Microsoft plug-and-play certified device, and it contains onboard sensors for temperature, humidity, pressure, and also motion. It's currently powered up, connected, and sending data to my IoT Central application, and it's sending telemetry about every 5 seconds. So now that I've introduced you to my device, I want to move on to our first scenario, which are rules and actions. So rules in IoT Central allows you to monitor the events coming in and then trigger an action when a certain condition is met. So here I've created a simple sensor overheating rule. So let's drill down into this rule and see what it's currently doing. When you create a rule, you have to target your devices. And we do this by associating a rule with a device template. You can still target an individual device within this template or groups of device by specifying additional filters. Next are conditions, which are the statements which must be met or satisfied in order for your rule to be triggered. You can create a sliding window which will aggregate your telemetric values. You can also add multiple conditions to stack using an and or statement. So in my condition, I'm simply looking for events where the temperature is greater than 20 degrees. Quite simple. But depending on your requirements, you can also create other telemetric conditions. For example, if your device has GPS capabilities, you could use the device location to create a geofencing rule to notify you or trigger an action when an asset is leaving a geofence location. The last part of my rule are actions. Actions are what you want to happen when a condition is met. In IoT Central, you can create actions to send an email, call a webhook or an API endpoint, or an Azure Action Group. My favorite are Logic Apps and Power Automate because they provide you with a powerful low-code way of connecting your IoT Central application with your other line of business systems and applications. So what I'm going to do here is to enable my rule. And whilst this is starting up, I'm going to go and jump to the Power Automate Cloudflow, which is at the center of this integration. So this Cloudflow is quite simple. The trigger is based off the IoT Central version 3 connector. So the IoT Central version 3 connector is one of the hundreds of connectors available on the Power Platform. And this particular connector contains many actions that allows you to interface with your IoT Central application, from managing devices, managing properties, accessing telemetry, and even executing commands on your device. This Cloudflow will monitor the sensor overheating rule we saw earlier within my IoT Central application. Once triggered, it will go and create a new record in IoT Alerts table in my Dataverse environment. It will also go and add in some additional parameters to provide context to my user from within Connected Field Service. So let's go and go over to Connected Field Service and have a look at the alert that should be generated. So in our Connected Field Service, I'm going to go to Primary Alerts and do a refresh. So in Primary Alerts, we can see the primary alert which has now been created by our rule. And the primary alert is really just a roll-up of all the individual active alerts relating to each event for this device against this rule. If we click on the primary alert, we can see all the associated information, including the time that the alert was triggered, the device that triggered the rule, and the customer asset that was associated with the IoT device. We can also see the telemetric value or properties of our event, including any cloud properties, as well as the temperature of the device at the time that the rule was triggered. So I've shown you how easy it is to use rules in action to monitor your events and trigger an action to create an IoT alert. However, in our example, we had a hard-coded temperature, and depending on your requirements, it may not be as possible to convert your requirement into a condition. What if you didn't know what an abnormal temperature is? What if you wanted to use machine learning to perform anomaly detection to create IoT alerts? With IoT Central, Azure, and also the Power Platform, you can do all of that, again, with little and no code. So let's look at how you would do this. So what I'm going to do here is I'm going to go back into IoT Central and look at data exports. So data exports are a feature or function within IoT Central that allows you to monitor and take your events coming into your application, but this time enrich it, so add additional information to it, and then push those events to other Azure services as part of your IoT solution. So to set up a data export, we first need to set up a destination, which will let your application know where in Azure you want to send these alerts to or events to. So currently, IoT Central supports various destinations from blob storage, event hubs, service bus, and also API endpoints or webhooks. So here, I've already set up a destination to an event hub. And the idea here is that my event will come into my application, get exported to my event hub, which I'll then stream to an anomaly detection service that I'll walk through very quickly. Once you've set up your destination, you can set up an export job, which will allow you to specify the data you want to export. You can specify any enrichments. So enrichments allow you, as I mentioned, to add information or properties to your events so that you can access these same properties and data later downstream. And finally, the destination, where you want to set it to. I'm going to go and enable this export job. And once this is enabled, what's going to happen is the events are going to come from my device to my application. It's going to get enriched with these two properties, and it's going to get exported to my event hub, which will then act as an input to Azure Stream Analytics. So let's go over to Azure Stream Analytics and see what that's all about. Azure Stream Analytics is a fully managed analytics and processing service. It's used to analyze and process large streams of data. But one of the great things I like about Azure Stream Analytics is that it contains out-of-the-box machine learning capabilities. This is great because it allows organizations who may not have the data science expertise or really the time and resource to create, train, and maintain custom machine learning models. But it still allows them to experience the benefit of real-time anomaly detection. So in my stream analytics job, I've set up an input, which is the event hub, which is also the destination we saw earlier. And the events are going to come into my service and pass into this query. So this query looks very similar to SQL, if you're familiar. And all it's really doing is it's calling the spike and dip function. The spike and dip function is one of the two out-of-the-box machine learning anomaly detection functions available in Stream Analytics. And this function takes in 4 parameters. The first parameter is the value you want to detect anomalies with, so the temperature, a confidence level, which you can adjust up and down to tune your sensitivity of your model, the number of events to train your model, and also whether you want to detect both spikes and dips or one or the other. This function will then return 2 outputs, a p-value score between 0 and 1 to determine a flag of whether that event is an anomaly or not. What I'm doing in this query then is to take all the events which has been classified as an anomaly and passing that into an output sink. And this output is a service bus queue, which, you guess it, I have a Power Automate Cloudflow monitoring that queue to create an IoT alert. So what I'm going to do here is I need to go and trigger my anomaly detector to be able to detect that anomaly. And the easiest way to do that, or quickest way to do that, is to use my hairdryer here to blast hot air into my IoT device, heat it up so that my anomaly detector will detect that anomaly. So I'm going to go on mute for about 5 seconds because it's going to get a little bit loud. Okay, so I've heated up my device for about 5 seconds. Before I go into connected field service to have a look at my device, what I want to do is go back to IoT Central and have a look at what's actually been happening with my device. If I click on my device, I can see that the green line is the temperature. It's definitely experienced the spike in temperature. So you can see it started off at 29 degrees and it went up to 44 degrees, so that's good. If we look at the raw value, it's definitely gone up. And again, before I go into my connected field service, I'm going to go to the Cloudflow, which is at the center of that integration. So this Cloudflow looks very similar to the one in the rule in action example. The only key difference here is that I'm using a service bus queue to monitor my anomaly queue. I've got a pass JSON action to extract some key data that I need from my, my service bus message. And then I'm using the same Dataverse connector to create an IoT alert in the IoT alerts table. And I'm again providing just some information to this alert to provide information to the user. So let's go over to connected field service, go back to the IoT alert screen, and you can see now I have a temperature sensor anomaly detected alert. If we click into it, we can see the time that it was triggered. We can see the device, we can see the temperature, and also we can see the score from our anomaly detector. So now I've shown you how we can take events from our device into IoT Central, export it to other services within Azure to perform anomaly detection, to create an alert back into connected field service. So to round that off, what I'm going to do now is to go through the business process flow to convert this into a work order and show you how we can send work order updates back into IoT Central against this device. So the first step is to just create a case. So this is a standard business process flow from Connected Field Service. And I'm just going to go and step through the process to get the work order created. So once we've created the case, we're going to just give it an incident type. We're going to go and create the work order. Again, I'm just going to specify the mandatory details and save. So this should now create a work order. I should get a work order number, and I should be able to see the status of this work order as unscheduled. Great. So now my work order is number 5. It's currently unscheduled. So if I go back into IoT Central and go to Overview, About, you can see I now have a work order number of 5. It's currently set to unscheduled. And then what I'm going to do here is I'm going to go back into Connected Field Service and assign a technician and schedule a technician on the job. So whilst we're waiting, I currently have a technician that I know is pretty hardworking. So let's zoom in. And we're going to just set him on the 15th. Set some times. And exit. So if we now go and move this to the next stage of our business process flow, we can now see that the status has now been set to scheduled. And if I now go back to my IoT Central application, the device has also been scheduled. The scheduled date has been updated to the 15th with the technician name. So before I wrap up, I just quickly want to go through the final Power Automate Cloud Flow. So this one's a little bit more complicated. It has a trigger for Dataverse to monitor my work orders table, and it will look for added or new or modified work orders. I will then go into the work order to get the IoT alert associated with that work order, and I'll get the device ID because we need the device ID to reference the IoT device in IoT Central. What I then do is check the status of the work order, and depending on the status, I will either update some properties against my device, or I search for the booking, and depending if I find the booking, let's scroll over, I will update different properties of the device. So this concludes my session for today, Introduction to Azure IoT Central. I hope you found it both interesting and informative. Please complete the Fusion Development Cloud Skills Challenge and download the Fusion Dev ebook. Stay connected, keep learning. Thank you.